The first type of workload we will talk about is computer vision. This is the ability for an artificial intelligence system to process data from images and video. Within computer vision itself, there are 6 scenarios we will cover here: image classification, object detection, semantic segmentation, image analysis, facial detection and recognition, and optical character recognition, also known as OCR. The first scenario within computer vision is image classification, sometimes referred to as image categorization. With image classification, we want to define the subject of an image. If we send the image to the right-hand side through a classifier, it might come back to tell us that the subject of the image is an animal, or more specifically, a dog. The second scenario is object detection. The goal of object detection is to create tags for each interesting thing in an image. In the image on the right, we see a series of tags including water, sky, skyscrapers, and a reflection. We can use these tags in several useful ways. For example, suppose we have a room containing top secret information, and we want to know whenever a person is in that room. We can set up cameras in the room and have security personnel monitor the room, but human eyes can only observe so many things at a time, and boredom can set in when observing a nearly static screen. As an alternative, we could perform object detections on the video feed and alert the security personnel whenever a camera detects something which looks like a person. Another good use for object detection is searching for images. If I want to find the perfect image to fit a blog post, searching for that image can be time-consuming. Tags on images help reduce the amount of time needed to find images, but humans are not always great at consistently tagging things. That's where an artificial intelligence system can come into play, reducing tedious labor and adding value. The third scenario is semantic segmentation. This scenario is a bit more complicated than the tagging example in object detection, as not only do we want to identify that there is something on an image, we want to specify down to the pixel level where on the image the thing is. And of course, when we start to detect things at the pixel level, the computational cost will be increased because we might need a better and computationally heavier algorithm and a faster computer. In this example, Microsoft Research collaborated with a Chesapeake Conservancy and Esri to train a model which takes aerial images as inputs and returns pixel-level classification of terrain features. Interestingly, in this particular image, the trained model was able to detect a water feature in the top center of the last predictions image, which was not included in their ground truth values. In other words, the model picked out something based solely on this aerial photograph that a human observer missed. The fourth computer vision scenario is image analysis. The purpose of image analysis is to provide a description of the contents of an image. Image analysis techniques provide more of a literal description of the contents of an image rather than a creative or context-rich explanation. For example, the description for this image is quite reasonable. A car parked on a city street, but we can add a considerable amount of context to it, such as somebody snapped the photograph at night in Manhattan with a long exposure time in order to capture a yellow taxi cab stopped at an intersection. The fifth scenario for computer vision is facial detection and recognition. Given an image, we might first ask, is there a face in the image? And once we identify that there is a face, we naturally would like to know more. How many faces are in this image? Who are the people those faces belong to? And what are the characteristics of the people in the photo? For example, Microsoft runs a site called howold.net, in which you can upload an image and get an estimation of the age of the person in the photo. When trying it on one of our illustrious data scientist instructors, The site came back with a prediction that the data scientist was 36 years of age at the time the photo was taken. We'll leave it to you as to the truth of the matter. Facial recognition can quickly become a serious privacy issue. And in the next section, we will cover the topic of privacy a bit further. The final computer vision scenario we will cover here is optical character recognition, or OCR. With OCR, we want to read printed or handwritten text in images, extracting that text in a usable format. In other words, given an image, we are asking the question, what printed or handwritten text appears in this image? OCR technologies have been available for decades, and researchers and companies have put significant resources into improving the methods for recognizing text in imagery. We will cover computer vision in detail in a later lesson.